Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.33. While solving this problem, we will be using Kirchoff's voltage law. This law states that sum of supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. According to this law, a cumulative supplied and dropped voltage in a closed loop is always 0. We also will be using electrical power formula. Basic equation for the calculation of electrical power is P equal to V multiplied by I, where V is the voltage across element and I is current through that element. Now move towards the problem. Exercise problem number 2.33. Find voltage VBA and power absorbed by dependent voltage source in given below figure. When 10 volt source absorbs power of 2.5 milliwatt. This is the circuit diagram of given problem. We have to find voltage between these 2 points labeled as VBA, which is indicating that B would be on higher potential than point A. And other useful information that is provided in this scenario is 10 volt source is absorbing power of 2.5 milliwatt. Using this information, we can calculate current through this voltage source, and this same current will also be flowing through the rest of circuit because of series connection. So first we will calculate current of this voltage source using power formula P equal to V multiplied by I. In this formula, we know the value of power and voltage, so we can calculate current. Enter the values inside this formula. Power is 2.5 milliwatt and voltage is 10 volt multiplied by I. Now divide on both sides with 10 to calculate the value of current I, that will become 250 microampere. So 250 microampere current is flowing through this series circuit. We have calculated the magnitude of current through this circuit, but still we did not identify the direction of current. So now we will identify the direction of current inside this circuit. If we again focus in this scenario, it is provided that 10 volt source is absorbing power. And we know that in order to absorb power through an element, the current should enter from the positive terminal of that element. So in our case, the current should enter from this terminal of voltage source in order to absorb power by this voltage source. Current can be entered to this terminal only in that case when the current will be flowing in clockwise direction inside this circuit. So with the help of this point, we can conclude the direction of current inside this circuit, that will be clockwise direction. Up to this point, we have identified the direction of current inside this closed loop circuit along with its magnitude. Now we have to make polarity notation across these two resistive elements according to the direction of current. So we know that the current entering terminals are taken with positive sign and current leaving terminals are taken with negative sign in the light of passive sign convention theory. We know the value of current inside this series circuit along with its direction, so we can calculate voltage across these resistive elements. Voltage of this dependent voltage source can also be calculated using the voltage value across this resistance. So now we can calculate voltage VBA. For that purpose, we will apply Kirchoff's voltage law inside this semi-closed loop. Basic equation of Kirchoff's voltage law is provided here. We will use this equation to calculate voltage VBA. Start writing Kirchoff's voltage law from here. Current entering terminal is positive. Here I would like to mention that the direction of current we already have calculated, that is clockwise direction. So current entering terminal on this point is positive. VBA will be taken with positive sign. Move to next element. Current entering terminal is negative, so voltage of this voltage dependent source will be taken with minus sign, minus 2Vx. Move to next resistive element. Current entering terminal is positive, so voltage across this resistive element, that is the product of current through it and the value of resistance, 3 kilo ohm multiplied by 250 microampere, will be taken with positive sign. Move to last resistive element. current entering terminal is positive, so voltage of this resistive element, that is the product of current through this resistance and the value of resistance 10 kilo ohm multiplied by 250 microampere, will be taken with positive sign. Now solve this equation, open these brackets and multiply values together. Product of 3K and 250 microampere will become 0.75 volt, and the product of 10K and 250 microampere will be 2.5 volt. Inside this equation, two variables still exist, so we cannot calculate value of voltage VBA. For that purpose, we have to omit Vx from this equation. Value of Vx is equal to the voltage across this 10 kilo ohm resistance, but opposite to the polarity of actual voltage. So the value of Vx will be minus 2.5 volt. The actual voltage that was appearing across 10 kilo ohm resistance is 2.5 volt, which we already have calculated, but Vx is the opposite to these actual voltage. So Vx will be minus 2.5 volt. Now place the value of Vx inside this equation. The equation will become VBA minus 2 into minus 2.5 plus 0.75 plus 2.5 equal to 0. Open these brackets. This minus 2.5 will multiply with minus 2 and it will become plus 5. Now add these constants together. These will become 8.25 and place this 8.25 volt on the other hand side of equal to calculate value of VBA. That will become VBA equal to minus 8.25 volt. We have calculated the value of voltage VBA. Now we have to calculate power absorbed by this dependent voltage source. We will use basic formula of power calculation, which is the product of voltage and current. Voltage of this dependent voltage source is 2Vx and the value of Vx is minus 2.5. So voltage across this dependent voltage source will be the product of 2 into minus 2.5 volt. And current through this dependent voltage source is 250 microampere, but with minus sign, because the direction of current is clockwise and it is entering from negative terminal of this dependent voltage source. Now open these brackets, multiply minus 2.5 volt with 2, it will become minus 5 volt, and multiply minus 5 volt with minus 250 microampere, it will become 1.25 milliwatt. So this was exercise problem number 2.33. Thank you. See you again in next video.